Hello, this is our first notes video that you'll be assigned, section 1-1. Today is 8/26/20, and I'm going to go a little bit fast when I take online video notes, and that's because you can rewatch it, you can pause it, and take your time. But just in terms of watching minutes and some of the time it takes to load up, I'm going to keep these as short as I can. And that means I just kind of go through it. You can always ask questions and pause the video and again, watch it again. All right, so just to recap a little bit for Math 1, a develop understanding task. Cell phones often indicate the strength of the phone signal with a series of bars. The logo below shows how this might look for various levels of service. Figure 1 has 1 bar. Figure 2 has 3 bars. Figure 3 has 6 bars. Oops. And figure 4 has 10 bars. Assuming the pattern continues, draw the next figure in the sequence. So you want to have a figure that looks the same in terms of ascending order. So then there's 2, then there was 3, then there was 4, then there was 5. Now what I often hear from students is, I can't draw. You don't have to be a phenomenal artist, but you do, if it says to draw the next figure, then that's what you want to do. So there are 15. How many blocks would be in figure 10? Well, this is only a 5 block figure. So to make it a 10 block figure, and I will have students that do that, believe me. But then if I take it to the next level and say, oh, what would be figure 1000? Then you'd be here drawing for a while. So eventually you always need to draw a table. Okay, so then our table, we'll call it the figure number. I hope I'm still in the square. Nope, I'm not. The table number, and then the figure number, and the number of blocks. Okay, so in figure 1, we had 1 block. In figure 2, we had 3. In figure 3, we had 6. Sorry, I haven't written all summer. Usually my first go with writing is a little bit tricky. And now with all this technology, we are crazy. So if this pattern continues, we want to know, oh, and I'm off the grid again, how many there will be in figure 10. Okay, so if you recall from Math 1, we need the first difference and the second difference to start to see some patterns. I'm going to use a different color just to kind of make it pop. Oh, and I'll lock that puppy. All right, my first video, they're going to get better. I'm kind of doing this one on the fly because, yeah, it's the first week and things are not cooperating, including my pen. Okay, so the difference between 1 and 3 is 2. The difference between 3 and 6 is 3. The difference between 6 and 10 is 4, 10 and 5, 5, and so on. Okay, so what you can see is, oh, it goes up by 2, it goes up by 3, 4, 5. So if this pattern continues, 6, 7, 8, 9, 10, etc., we're eventually going to get to 55 blocks. Am I still in there? Yeah. I'm using a new Screencastify. I used to do Screencast-O-Matic or WeVideo, or now we've got Jammy and we've got Cami. It's all very cray-cray. Okay. Graph the data from number 2. So I have the luxury of just kind of putting that right next to us. But if you can recall that, just so I don't make you too dizzy, maybe you could put your paper next to that so that we can graph it. But I'm just going to graph that table. I guess I could redraw it here. 1, 2, 3, 4, 5, 10, and the output. So remember, the input, this is your independent and your dependent. A lot of you always call it X and Y, but it depends. If it's a real life example, then you have to use whatever it was. So this would be the figure number here, and this was the number of blocks here. So the number of blocks depends on the figure number. All right. All right, I'll use another color. I went to University of Illinois. Our colors are orange and blue. So I'll just keep it simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's see, what do we start with this one, the table? We could start at 5 because it gets up to 55 pretty quickly. And that's a 10. So, do I want to go by 5s? Yeah, I'll go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. I'm kind of marked. I should be consistent with those. The increments, don't like go by 2 and then go by another value, what have you. All right, 1, 1. 2, 3, so we're barely off the ground here. 3, 6, 4, 10, 5, 15, and then 10, 55. So if you had values in between, I think I put them up last year. Let me. Some of the values in between 6, 21. Because I'm just adding 6. Now I'm going to add 7. Then I'm going to add 8, 9. I'll squish. So when a graph is just a sketch, you can call it just that. You can start to see this curve. What you don't want to do is make it a straight amount. What you also don't want to do, and now I use pen, is connect these. This is what we would call a discrete function when you don't connect it. Most of our things are connected, but technically when you're just talking about those values in between, 621, 728, I don't know why I'm obsessed now on this, but I am, 836, and 945, and then 1055. Okay, so the function is not linear. Let's take a few notes here. Okay, so we're just going to kind of talk about, I'm going to scoot this over, some of the characteristics. All righty. The function is not linear. It's not exponential. The domain is the natural numbers. Domain is input. Now, a lot of this, I know we're dusting off the cobwebs because 2 reasons. One, it's been a long summer, but it's also been a very long spring. So a lot of your Math 1 material, we're going to have to clean up because some of you got further than others. Some of you may even have an incomplete. Who knows? But I doubt it. I think I have that list. The function is increasing. I'll talk about each of these. As I mentioned, I'm going to kind of go fast, and you can pause if you want. And the minimum value is 1, 1. We'll talk about a lot of this all year. Okay, so let me make sure that's all on the screen, and then I can chat about it. Okay, so some of the characteristics. The function is not linear. It doesn't have a constant rate of change, the slope. The function is not exponential. It does not have a ba-boom, ba-boom, ba-boom multiplier, okay? The domain is input, so that's along here, the x-axis. And that is the natural numbers, 1, 2, 3, 4. The function is discrete. I mentioned that. I shouldn't have connected that, but I don't have any whiteout. So, and the function is increasing. That's pretty self-explanatory. It's rising. And the minimum value is 1, 1. So we'll talk a lot this semester about minimum value and maximum value. Okay, so we'll get into quadratic functions and absolute value functions. So we'll kind of move on from just linear or exponential. Okay, so that's just a little bit of dusting off the cobwebs. If you were on your own and I said, what are some characteristics? If you didn't come up with all those, that's okay. But as you take notes, I would like you to write whatever we write as a class or me as the teacher. All right. Okay, a change of topic, a bit of review, and some algebra skills. All right, so throughout this chapter, this semester, you are going to have to know your basics, I'll call it, okay? So in this case, we're talking about the distributive property. And other basics will come up, and I'll try to, again, partly because of our funky spring that we had, and partly because of just, you know, kind of typical summer loss. So distributive property is, you might recall from like making the rainbows or what have you, but you're multiplying something to, it's the parentheses. So I'm making sure that A gets distributed to B and to C. So I multiply. If these are then like terms, you can combine them. Typically they wouldn't be, because if they were like terms, you'd add them in there. So I'm going to distribute the 5 to get 5x and distribute that. 5 times a positive 2 is 10. Positive 10. Okay. And you don't have to make the rainbows. Again, I'm just kind of refreshing your memory. Negative 12x minus 18. I'd really like it if you wrote minus 18 as opposed to plus a negative. Okay, a negative times a positive is a negative. Don't forget your variable. Sometimes a lot of us forget that variable. And a negative times a negative is a positive. I put a slash through my 7. I had a college professor do that. So I just picked up on it. It kind of separates it from looking like a 1 sometimes when you get messy. So x plus x is 2x, and x times x is x squared. So this is a big deal, how these are different. Sometimes when kids see x times x, they want to say it's 2x's, but it's x to the second power. So when I multiply x times negative 9x, this is going to be negative 9x squared plus 6x. And you're done. Those are not like terms. 4x times 2x is 8x squared plus 20x. Okay. Half of 8x is 4x. Half of 20 is 10. But this minus sign means a negative times a positive is going to be a negative. Okay. Now, oftentimes kiddos get, I'm gonna not do the rainbow here, because I know a lot of you guys don't do the rainbow. I'm sort of just being dramatic. First day. Okay. So a negative times a positive, I know it's going to be a negative. So if you use your calculator, you're going to do 6 divided by 7 times 21. But I bet a lot of you won't reach for it. So you're going to say 7 goes into 21 3 times, and 3 times 6 is 18x. Alrighty, and we do have x squared. So that's about the toughest you're going to get. Now I have a negative times a negative, which is a positive. And again, 7 goes into 14.